Hello students, in previous lecture we have discussed about the alkenes, that is one of the hydrocarbon. The alkenes which are unsaturated hydrocarbons which containing at least one carbon-carbon double bond. In previous lecture we have discussed about the UPSC nomenclature, common name, isomerism exhibited by alkenes, and few physical properties of alkenes. The isomerism exhibited by alkene, that is of structural isomerism, that is chain isomerism and position isomerism, as well as alkenes shows geometrical isomerism, which is also known as cis-trans isomerism. Cis-trans isomers of but-2-ene, which is discussed in detail in previous lecture. Today we are going to discussing on preparation methods of alkenes. See here, all of you aware of that there are generally two types of methods of preparation of any organic compound, that is industrial method and laboratory method. Industrial method, which is also known as commercial method, in which large scale production of organic compounds takes place. Today we are going to discussing on these all methods of preparation of alkenes. Then first of all, industrial method of production of alkene. Then see here, the petroleum, which is also known as crude oil, and the natural gas which is associated with that petroleum. All of you aware of that what is petroleum or crude oil? Petroleum is nothing but it is a high molar mass organic substances which is obtained by decomposition of remains of plants, dead plants and animals. When these plants and animals, dead plants and animals, get buried into the deep in the earth crust because of high pressure and high temperature, they are converted into petroleum like products, that is crude oil. And with petroleum, natural gases like methane gas, propane, butane, ethane are associated with the petroleum products. And when these petroleum products undergoes distillation, fractional distillation of these petroleum product takes place, then after purification of these petroleum products by fractional distillation, it gives different types of alkanes as well as petrol, diesel, kerosene like products are obtained here. All of you studied about that in preparation of alkanes. Then today we are going to study about the preparation of alkenes from petroleum. Then petroleum or crude oil or natural gases when undergoes cracking process. Here, cracking of petroleum takes place to gives different types of alkenes, which is a industrial method of production of alkene. All of you studied about that pyrolysis or cracking process of alkenes, which is studied in chemical properties of alkanes. Then I am going to remind about the cracking process. Then cracking process is nothing but it is a pyrolysis of alkane, pyrolysis of petroleum products. And what is cracking? Cracking means it is a breaking of carbon-carbon covalent bond present in the alkanes. That means, for example, propane, that is alkane, when it is heated at high temperature and under high pressure, that alkane undergoes breaking of carbon-carbon covalent bond, as well as here carbon hydrogen bond breaking also takes place, and it gives lower alkane, that is methane, and lower alkenes, that is ethene. That means propane undergoes cracking process at high temperature and under high pressure. It gives methane and ethene. That means mixture of alkane and alkene formation takes place. That is about the cracking process or pyrolysis process. Similarly, by cracking of petroleum or natural gas, it gives different types of alkenes, which is a large scale method or commercial method or industrial method of production of alkene. Then we will discussing on the second type of preparation method, that is small scale method, which is also known as laboratory method of preparation of alkene. Then see here, there are different methods of preparation of alkenes takes place in the laboratory. And first of all, I am going to discuss the preparation of alkene, that is by elimination reaction or elimination process. And this process is also known as 1,2 elimination reaction, or it is also known as alpha beta elimination process. Alpha beta elimination reaction. Then what is elimination reaction? Elimination means to eliminate, to given out few groups from the organic compound at a particular condition is called as elimination reaction. Then there are different methods of elimination process. That is, one of the type of elimination reaction is dehydrohalogenation of alkyl halide. Alkyl halide, which having general formula RX, that is alkyl chloride, alkyl bromide and alkyl iodide are the different types of alkyl halides which undergoes dehydrohalogenation. See here, D means removal of hydro means hydrogen atom and halo means X group or atom, and here halo group or atom is chloro group, bromo group and iodo group. That means removal of hydrogen atom as well as halo atom from alkyl halide atom when alkyl halide are boiled with alcoholic KOH. That process is called as dehydrohalogenation of alkyl halide. That means, see here, when dehydrohalogenation of alkyl halide takes place, when alkyl halides are boiled with alcoholic KOH, not the aqueous KOH, and X group, that is halo group of alpha carbon atom and hydrogen atom or hydrogen group of adjacent carbon atom, that is beta carbon atom, are removed from alkyl halide. That means here alkyl halide when boiled with alcoholic KOH, halo group of alpha carbon atom and hydrogen atom of adjacent carbon atom, that is beta carbon atoms, are removed to give alkenes. For example, alkyl halide when boiled with alcoholic KOH, that is here ethyl bromide, that is bromo ethane, when boiled with alcoholic KOH, it undergoes, alkyl halide undergoes elimination reaction, that is bromo group, halo group of alpha carbon atom. Alpha carbon atom, the carbon atom to which functional group is attached is alpha carbon atom. The halo group of alpha carbon atom and hydrogen atom of adjacent carbon atom. Adjacent means neighboring carbon atom, that is beta carbon atom, are removed to gives KBr plus H2O with formation of corresponding alkene, that is ethyl. See here, that is the dehydrohalogenation of ethyl bromide takes place, which gives the production of or preparation of ethyl. And one more example we will discussing here, that is propyl chloride, that is N-propyl chloride when boiled with alcoholic KOH. On boiling, it gives propene formation, that is CH3 CH double bond CH2. Propene formation takes place from propyl chloride. Here Cl chloro group or atom of alpha carbon atom is removed with formation of KCl, and H of, that is hydrogen atom of adjacent carbon atom, that is beta carbon atom, is removed, and here propene formation takes place by dehydrohalogenation of N-propyl chloride. Similarly, one more example, that is CH3, CH, Cl, CH2, CH3, that is 2-chlorobutane, 2-chlorobutane undergoes elimination or dehydrohalogenation process when it is boiled with alcoholic KOH. See here, the Cl group, halo group attached to this carbon atom is a alpha carbon atom, and there are possibility of 2 beta carbon atoms are there. Carbon atom present in CH2 and CH3. Then here possibility of formation of 2 different alkenes takes place. That means here 2 different type of alkenes formation takes place when chloroatom of alpha carbon atom and H atom of this carbon atom of CH2 group is removed, then it gives but2ene, but2ene, and when chloro group of alpha carbon atom and H atom of this beta carbon atom of CH3 group removed, then it gives but1ene, and here the major product which is obtained is but2ene, that is 80%, and but1ene which is prepared is 20%. Here the possibility of formation of 2 different products in which but2ene is a major product because it is a alkene which containing higher number of R group which is attached to the carbon-carbon double bond, or greater number of R group. There are 2 R groups attached to the carbon-carbon double bond, which is di-substituted alkene is prepared preferentially according to the Set-Gibbs rule. According to Set-Gibbs rule. Set-Gibbs rule. And the minor product obtained here is a mono-substituted alkene, that is but1ene. We will discuss in detail about the Set-Gibbs rule later. One more preparation method of alkene, that is dehydration of alcohol. Dehydration of alcohol is one of the elimination type of reaction. See here, dehydration, D means removal of hydra means water, that is removal of water from alcohol. That is the elimination process or elimination reaction, and that is the one of the type of elimination reaction. Then see here, the removal of water from alcohol takes place using particular dehydrating agent. Dehydrating agents, as reduction takes place using reducing agent, oxidation takes place using oxidizing agent. Similarly, here to carry out the dehydration of alcohol, dehydrating agents are required, and to carry out the dehydration of alcohol, different types of dehydrating agents are used, that is concentrated H2SO4 and alumina, that is Al2O3 like dehydrating agents are used to carry out the dehydration of alcohol. Here dehydration of alcohol takes place using concentrated H2SO4, but the elimination reactions takes place preferentially in tertiary compounds, then secondary and primary. That means preferentially elimination process or elimination reactions takes place in tertiary alcohol or tertiary alkyl halides, then secondary and then primary compounds. That means here preferentially that means tertiary alcohol undergoes easily dehydration. Here CH3, CH2, CH2, CH2OH, that is N-butyl alcohol, which is a primary type of alcohol which undergoes dehydration and using concentrated H2SO4. Here 95% H2SO4 is used at 413 Kelvin. Then OH group of alpha carbon atom and H of beta carbon atom are removed to gives butene, that is but1ene, and here with liberation of formation of water by removal of water molecule from alcohol. Similarly, in secondary alcohol, CH3, CHOH, CH2, CH3, that is a secondary butyl alcohol, which is known as butane 2-ol. Here dehydration of secondary butyl alcohol takes place using 60% H2SO4 at 373 Kelvin to gives here OH of alpha carbon atom and H of beta carbon atom. See here, there are two possibilities of removal of hydrogen of beta carbon atoms, because there are two beta carbon atoms which is adjacent to the alpha carbon atom, and here possibility of formation of two different products, that is two different alkene formation takes place when OH of alpha carbon atom and H of this beta carbon atom, that is of CH2 group, when removed, then it gives, that is but2ene. It gives but2ene formation takes place, while the OH group of alpha carbon atom and H of this beta carbon atom, that is of CH3 group, when removed, it gives but1ene, but1ene, that is butene. That means here two possibilities of formation of two different alkenes takes place, and here the alkene which is obtained is but2ene is a major product, that is 80%, which is a major product, and but1ene which is minor product, which is 20%. Formation takes place here, and here the two different compounds, that is but2ene and but1ene formation takes place according to the Sedgwick's rule. Here major product formation takes place is a but2ene, because according to Sedgwick's rule, potentially product which is obtained, that is alkene which having greater number of alkyl groups attached to the carbon-carbon doubly bonded. That means here higher substituted alkenes are formed here. Therefore, preferentially but2ene which having two R groups attached to the carbon atom which is doubly bonded, carbon-carbon doubly bonded, and here only one R group is attached to the carbon atom which is doubly bonded, carbon-carbon doubly bonded. That means according to the Sedgwick's rule, the higher substituted R group compound formation takes place preferentially. That means here the alkene which possesses greater number of R group attached to the carbon-carbon double bond is preferentially prepared here. Then the order of preparation of alkene is like this. That is the order of formation of alkene according to the Sedgwick's rule. See here, and the formation of alkene to which less number of R groups are attached to the carbon atom which is doubly bonded. See here, that is the order of formation of alkenes according to the Sedgwick's rule. Similarly, here di-substituted alkene which is but2ene is obtained preferentially or as a major product than the mono-substituted alkene, that is but1ene, which is a minor product. Then at last the tertiary alcohol, that is tertiary butyl alcohol, which undergoes dehydration and require 20% H2SO4 at 363 Kelvin to gives alkene, that is isobutylene. Isobutylene, that is 2-methyl propene formation takes place here by removal of OH group of alpha carbon atom, and there are possibility of 3 beta carbon atom attached to the alpha carbon atom, and if removal of hydrogen of any one carbon atom, any one beta carbon atom, it forms the same product, that is isobutylene or 2-methyl propene. See here, for dehydration of primary alcohol, 95% H2SO4 is required and temperature is 413 Kelvin. For secondary alcohol, 60% H2SO4 and 373 Kelvin. That conditions are required. And to carry out the dehydration of tertiary alcohol, 20% H2SO4 and about at 363 Kelvin, the dehydration takes place. The conditions are different. It is due to the preferentially tertiary compounds are easily undergoes elimination reactions or dehydrohalogenation reactions or dehydration reaction, and then secondary and primary. That is about the preparation of alkenes. Then there are two more preparation methods we will discussing in next lecture. Thank you.